So a ratio, in terms of our definition, you're just going to write it is a comparison of two numbers, and usually the most common ratio, whether we refer to it as a ratio or not, is a fraction. I'm going to get used to writing. Okay, so it's usually a fraction. So the way you're going to see ratios written would be like one of two. So then that's telling you, like, if we had $2 and you had one of them, we're comparing those. Oh, Christian, behind Vicky, two back behind me. So one of two. It can also be written with a or colon. It's a full colon, I believe. So I'm not an English major, but I think that's a colon. 1 to 2 is how that would get read, or it can get written out with the word two. So those are the three ways normally that we deal with a ratio. The majority of the time, in terms of things that you've been dealing with for a very long time, it's going to look like a fraction. Okay, so that's what the ratio can be written as. A proportion is two ratios that are equivalent. So the simplest way to think of this, let's do like 4/8. That's a ratio because it's comparing 4 to 8. So if we had, 8 pieces of pizza, when you get a pizza delivered from Domino's or something, and there's 4 slices, you took 4 of those 8. Yeah. So we reduce that down to 1/2. That would be considered a proportion. It's two ratios that are equivalent to each, or two fractions that are equivalent to each other. Okay. All right. It says we number the terms of a proportion. So again, all the proportion is are two fractions that are set equal to each other. So there's a couple different routes. I actually like doing A, B, C, and D. But when we say we can number them, we could do 1, 2, 3, and 4. So just general proportion before we start dealing with any numbers. Alphabetically, A is first and D is last. B and C are in between. And then obviously 1 and 4. 1 is first, 4 and last. 2 and 3 are in between. So when we start talking about the extremes first, what that just refers to is this is the first and this is the last. So A and D would be our extremes if we write it with variables. If we're doing this numerically, since the number 1 and 4 are the smallest and the largest, we would also say 1 and 4, depending on what we're using, A's and B's or numerical values. Means are the other numbers. So if I ask you what are the means, those are the ones in the middle. Remember what a mean is in terms of arithmetic mean is kind of the average, the middle number. So the means would be the B and the C. That's a bad B there. All right, and then here, 2 and 3, if we do it numerically. So it's easiest, to me, it's the extremes are the easiest ones. It's the first and the last. So A is first, D is last alphabetically, and then between 1 and 4, 1 is first and 4 is last, and the 2s and the 3s have to be the middles. Okay. All right. Example number 1. What this is saying is that x over y, if we compared x to y, that would be equivalent to 5/6. All this is getting at is there's different ways to writing these. So recall how 4/8 was equal to 1/2. These were equivalent to each other. The 4 became a 1, the 8 became a 2. So if we look at the way this one is written, the x is being compared to that 5, the y is being compared to that 6. So if we're going to flip the y and the x around, notice all I did is flip these around. The x still has to be paired off with the 5. And just like it was up here, the y still has to be paired off with the 6. So there's a lot of different routes we could take. We go to the next one. Again, notice how the x and the 5 are together. Let me do it this way. So we keep erasing all of this. And then the y and the 6 are together. So if we look at this now, notice how we took the x over the 5. So the x was on the left, the 5 was on the right. So if we're now going to write this, we would want to do the y over the 6. Just a different way of rearranging that. So real quick, see if we understand what I'm doing here. Try to do that one. If I give you 6 over y, the other fraction would have to be what over what? Yeah, him.
why is it y over 6? Why isn't it 6 over y?
Say that one more time now.
Why is it y over 6 instead of 6 over y?
For letter B?
Yeah, letter B.
So look at what I have highlighted here. See how the x gets compared to the 5? So they're kind of like married now. They're together. It's like this fraction up here. The 4/8 becomes a 1 over a 2. So the x to 5, the y is to 6. So notice how in this blue fraction, this numerator over here, the x is being compared to 5. Well, how I compared them here is vertically now. I put the x over a 5. So if I'm now going to rewrite this second one, that means I've got to be doing the y vertically over the 6. Okay, we went the variable to our number, so here I have to do variable to number on this one. All right, so now if this is 6 over a y, now we're using this one, right? 6 compared to our y. All right, what do you think for that one, Kim? Good, so this would have had to have been 5 over x. The number over the variable, and our other number was 5, our other variable was x. Okay, so just some different ways that these can get rewritten. All right, and then this is our big one here. It says the means extremes product theorem. So I'm going to write this with A, B, C, and D. So right proportion, we wrote this up above. We're going to use A, B, C, and D. Remember let's do extremes first, actually. The extremes are these guys. And the means are the middle numbers. So B and C are in between the A and the D. So the extremes are the A and the D. The B's and the C's are our means. The extreme mean product theorem just states that the product of the extremes is equal to the product of the mean. All right, so write that. That's really fancy math teacher talk for something that's actually really, really easy to write with variables. Notice what I have highlighted here. These are our extremes. So if I did A times D, that would have to equal the product of the means, and the means are the B and the C. So A times D would have to be equivalent to B times C. If we go and show that with the fraction that everybody knows, so let's go up to this guy, right? 4 over 8 equals 1 over 2. What this is simply saying is that if I did 2 times 4, that's 8. That better equal 8 times 1, which is also 8. Those have to be equivalent to each other. All right. So that's the means extreme theorem. It makes solving these really, really nice. So it's a nice little section to start with after a long layoff. Because what we're simply saying is the extremes, which are these guys. So you're just going to crisscross and we call it cross multiplying. So 7 times x, those are the yeah. Yep, butterflies. If I now draw in this blue one, there's Ahmed's butterfly. I like that. Like that. So what is 5 times 12? 60. Uh-oh, then everyone's gonna freak out about this. Divide by that. Oh god, it's not on home. We'll just write it as 60 over 7. I got a calculator out, so we do get some weird numbers today. 8.57. All right, we'll go with that. Can we see that yet? Yeah. Yeah, so our x would be 8.57. These, just be careful. We're definitely crisscross and multiplying still. So the means get multiplied together, the extremes get multiplied together. So the 8 times dx is pretty simple. I would just strongly recommend when we do the 4 times this x plus a 3, write that first using a set of parentheses, just so we understand that that 4 needs to get distributed to both the x and the 3. If you do that again, these are pretty nice little equations to solve. You'll go ahead and distribute. If you think you're really, really good and you want to distribute right away, feel free, but I would suggest just rewriting that first. All right, so solve, subtract our 4x. Divide by, hold on a minute. See, a little rusty myself after the long break there. So should get 4x is equal to 12, divide by 4, and x should end up being 3. All right. last one of these. So do C real quick. Let's see if we can get through that one. Let's see if we get a good number here. Yeah, should get a nice number. So if you get a fraction here, that would be bad. All right, so I'm just crisscross multiplying. So the extremes are the yellow ones in this case. Remember that, because eventually we're going to want to know what these are called here on this next page. So the 18 and the x are the extremes. So we multiply those together. And then the means, the b and the c. So we'll take this 6, multiply it by an x plus a 6. From there, we've been solving a bunch of these little equations. We just go through working our way. You're going to distribute. So we'll get that 6x and the 36. Subtract our 6x. So that we get 12x equals 36. What did you get, Cam? You had your hand up.
3.
Yeah, so we should get 3 if we get through that correctly. Okay. So that's the means extremes product theorem. All right, so now this one. Think that one through. See what you think. What would this have to have been? So you're basically going to write a new fraction over here. If this is what we ended up with, all I want you to do is fill in what did this numerator have to be, what did this denominator have to be. Just a different way of kind of testing you on that means extremes theorem. Now I got so many people to call on. I don't know what to do with myself. Crazy.
I'm just thinking there's so many more papers I can go look at.
Yeah, right. Yeah. All right, Jenna, what do you think is our numerator here? Good. Why'd you put 7 here? Good. So looking at this, we had a 7y right here. So when we crisscross, if the 7 ended up with the y, that told her that the 7 had to be right here. And then you said the 5 on the bottom, right? And then she put 5 here because the 5 and the x, when we crisscross, better give us this 5x that we get right there. All right. All right, same thing with number 4. If you weren't sure about that first one, what it was asking, now this should be a little easier. We just want to know, what does this number here have to be, and what does this number here have to be in this new ratio? All right, and Megan, what does the numerator have to be? Good. So she said 8 over 13, so that when we do 8, when we crisscross here, the 8 and the b give us this ab, and then when we crisscross here, the 13 and the a get multiplied together, give us 13a. All right. So that means extreme product theorem. Here's the thing that's a little weird. It says, remember finding the mean in algebra? This is something that you have done before. So if I ask you what the mean is, your teacher also probably would have talked about this as an average. So what's your average score? So when you look on your grade right now in Skyward, that's really your mean, that's your average. However, what we want to understand about that idea, you've never in your life probably had to differentiate because it's the only mean you would have ever talked about. So your definition of mean that you currently know from previous experience is actually called an arithmetic mean. So when we reference arithmetic mean, did you see anything pop up there? I don't know. Okay. Arithmetic mean, that's what we currently know how to do. So if I ask you to find the mean of 33 and 115, and it's the arithmetic mean, then it's exactly what you would have learned in the past. We add all of them up. In this case, there's just 2 numbers there. And then you divide by however many numbers that you added together. All right, so that is what, 148. We would divide by 2.
Wait, that's good.
Yeah, this should work out nice. Because 2 goes into 14 7 times, right, Cam?
Yeah.
And it'll go into 8 4 more times. So, right, did I mess up? 33 and 115 is 148 divided by 2. Yeah, it should be 74. Okay. Yeah, so we should get, that's our mean. Just keep in mind, though, this is your arithmetic mean. Yeah. Yep. We also, though, have a mean. There's actually 3 different ones. The one that we deal with most of the time is the arithmetic. We also have a mean that is called a geometric mean. Obviously, then different than this. So this is certainly something you're going to want to know. But the geometric mean is now a little bit different. Okay, and it's called a mean proportion. So let's kind of go through number 5 and talk about what this actually is. So what this says is find the geometric mean between 2 and 8. I'm going to do it geometrically with a rectangle first. So draw in a rectangle. This isn't perfectly to scale, but make one of them a height of 2 and a length of 18. So make it long. If I ask you for the area of this, area is nothing more than your base times your height. So 2 times 18, our area would be 36. So that's how much space we take up, our area that this rectangle would take up inside of it. What a geometric mean is, and I give you this one because it's pretty straightforward and easy to do without having to set up a proportion just yet, is what is the square? So if I now drew a square, what would our 2 sides need to be here and here to get this exact same area? And if it is a square, this is actually what we just left off with last chapter, right? We were kind of concluding some geometry topics. Now we're getting into new geometry topics. If this is a square, all these sides are congruent. So what is the only number I could assign to all 4 of those sides so that when I multiply the base and the height together, I will still get this 36? It has to be what? 6 and 6. So when we, come on, you. So when we find a geometric mean, that's what we're doing, is trying to figure out what's that perfect square that would give us the area that we originally have, okay? Here's how we're going to set this up initially. So set up your proportion. We'll show how we can do this algebraically when they're not nice numbers, because most of us could probably have done that one very easily in our head now that we know that that's what we're looking for. The reason it is called a geometric mean is that these are your 2 means. So remember, the means are the middle numbers, the B and the C. So what we would want to do is assign one of these as a 2 and the other one as an 18. Then A and B, keep in mind, we're trying to figure out what the perfect square would be. Don't be like the 6 and the 6, don't those have to be the same number if that's what we're really looking for? So we're going to make these the same exact number, and we don't know what that number is yet, so we're going to use a variable, but they'd have to be the exact same variable. So make those x's and x's. If we now solve this like we did those previous handful of questions, so cross multiply, so x times x would give you x squared. 2 times 18 would give you 36. And then recall how we get rid of square root or squares. We did that with roots, square roots. So if I now take the square root of this, recall we technically get a positive and a negative. If you remember, we did a bunch of those last semester. But if it has to be the mean of these 2, and these are both positive numbers, the 2 and the 18 up here, that's the only reason we're going to ignore the negative and say that our answer was 6. And isn't that what we got geometrically right here? All right, 6 and 6. Yeah, it's just when these are not nice numbers, this is a nice thing to rely on long term. Okay.
So we shouldn't think about the positive and the negative.
With this, the negative will never, unless I give you a negative number, I should say. But if I give you positive numbers, notice how doesn't 6 definitely fall in between those two? So it's still kind of in between, but don't think it's the middle like the regular mean.
Okay.
So the -6 doesn't make any sense if we're doing the 2 and the 18. It's got to be only the positive. Now, if I change these to negatives, now we might have to rethink this a little bit because now it has to fall in between -2 and -18. But since these are both positive, there's no way the negative would apply that.
Okay.
All right. Okay, and then there's another little way too that we can do these, but let's do one more. Yeah, I don't like jumping right to this. Add a 5. Hopefully you got a little room here. I want to do one more before we give you this. So add a 5b. Can you see that up here? Yeah. And we'll say find the geometric mean. What did I give? I gave 6 and 54. So we'll do between 6 and 54. And the reason I like this one again is we could do this geometry with some shapes if you're really, really good with some big squares. Where if I go ahead and say this is 6 and this is 54, if we multiply those together, we find our total area. The area of this is 324. That's the area of that rectangle. So underneath this, once I figure out how to erase this, my pen will start to work. Draw a square now and see what those two sides would have to be so that we get 324 once again. So what we're hoping for is it's a nice number, right? Same number here, same number here. If it's a square, that multiplied together are going to give you that. All right, what do we get, Kim?
18.
Good. 18 and 18, multiply those together equals 324. How'd you get that, Kim?
I did it the other way. We set up the
Okay, good. So what he did, sorry, I'm running out of room. Let me just get rid of all this. I'm not going to have you do this one anyway. So what he did is he actually set up the equation. So if he did that, totally fine. What that really means is those are your means. So this 6 and 54, one goes here, one goes here, one goes here. Crisscross and multiply, so x squared equals that 324. That's what 6 times 54 would be. And then how do we get rid of that squared, Kim? Good. So we did the square root. So x would equal 18. The reason I like showing those so you can see it geometry-wise is aren't we really doing, anybody else do it differently? Anybody not set that up and be able to figure that out without going through all that work? Nobody has a different way of kind of thinking this through. No. Let's see how quick I am coming up with another one. Aren't we really? So when I give you this 2 times 18 and I get this 36 right here, what can I do to 36 to get 6 right away? Instead of setting up that big proportion and going through all that work. And the same thing here, it would be the same exact thought process here. Right. So take the square root of 36. Doesn't the square root of 36 equal 6? You may not know this one. The square root of 324, I promise you, if you did the square root of 324, it's going to give you 18. So every single time, aren't we really doing? So this is a different way of approaching this, and it's kind of what we want to know for this next problem. Aren't we really each time to find the geometric mean? Aren't we really always going to be doing the square root of the two numbers multiplied together? Because doesn't this just give us the square root of 36, which is 6? Say it again. Yeah, sure. Yep, good. So let's say I now ask you to do it with this one. Aren't I really just doing, so the geometric mean, isn't that really just the square root of 6 times 54? Because that's going to be 324. The square root of 324 is going to give us that 18. So go back up to where we set up the proportion. So in the geometric mean, we set up a proportion up here. But the geometric mean can also be found by simply taking the square root of the two numbers that we're looking for the geometric mean of. And we don't have to set up that proportion. Even though the proportion is perfectly legitimate, we end up every single time with a times b, and we want that square root, okay? The reason that is important is because of number 6. It says, this is the geometric mean now. So I'm telling you, this is the geometric mean. What are the two numbers? We know one of them that we multiplied together, took the square root of to get 15. So if we are now knowing that this is our answer, and it's the product of 5 and some number, what our geometric mean always is the square root of the product of our two numbers we're looking for the mean of. Well, don't we know one of the numbers? It's a 5. The other number is what we're trying to solve for, so we'll leave it defined as a variable. But don't we know the left-hand side? Don't we know what the left-hand side is equivalent to? We actually know the geometric mean. It's 15, right? So we set that equal to 15. So just kind of a different way, having to make you work backwards a little bit. So just like we get rid of squareds, so up here, whenever we had like x squared equals that 324, and Cam said we take square roots to get rid of them, the way we get rid of square roots is we need to square them. So now we want to square both sides. So the square and the square root cancel, so that's 5b. 15 squared is 225. You have a very simple little equation now. Divide, oh boy, what is that, 45? I think I did that, yeah. That has to be our answer. So if we tested that real quick, because we got 2 minutes, if I now said our geometric mean should be the product of 5 and 45, isn't that really the square root of 225? And then that, in fact, gives us the 15 that we were supposed to get when this problem got set up. Okay? All right. That is a wrap. So I am going to be that guy to give you homework on your first day back. It's just the next 2 pages. You're going to do 1 through 20, you can see here. And then you'll see that I've crossed out 15 and I've crossed out 17. So it's just the next 2 pages. It'll say the 6.2 homework. You are not doing 15 or 17. So you may want to cross them out so you don't struggle with those later tonight and say we didn't do those in class, because you would be correct. Okay? All right, with that, we're done. People at home, check out. People here, really nice to have people in front of us. Enjoy the rest of your day. Yeah. I honestly, I would still probably prefer I won't be mad if you just hand me a hard copy tomorrow.
Okay.
But at least Canvas, everything goes into one spot, and then I can grade them real quick. But if you want to hand in a hard copy, that's okay. All right. Ms. Tyrell also made the announcement, for those who have been here, some days on the overflow days, you may have been going to different places. There are no overflow days. So whatever your advisory is normally, because you guys are all sophomores, probably where you would have gone last year every day, you just go there now every day. Okay, so there is no overflow like going to the grill, commons, any of that stuff. Okay. Make sure you stop recording.